This video is about logarithmic functions. And what I want to talk about is how logarithmic functions are related to exponential functions. So let's use this table as our example. Now this table can represent a function. So what I would like you to do is to determine the symbolic form of the function represented by this data. So go ahead and hit pause and work on that for a little bit. See if you can determine the symbolic form, and then press play and we'll check your work. Okay, hopefully you've done that. So let's take a look. Now, if I want to read this table from left to right, I can see the left column as my inputs, x, and of course that means that f of 0 equals 1, f of 1 equals 3, f of 2 equals 9, and so forth. And hopefully you've noticed that the exponential function 3 to the x fits this criteria perfectly. 3 to the 0 is 1, 3 to the 1 is 3, 3 squared is 9, etc. However, we can also read this table from right to left. Notice each of the numbers here on the right have exactly one number associated with them on the left. So if we see the right column as our inputs, every input has exactly one output. So it is a function. I'm going to call this function g of x for right now. And so now let me write down the symbolic form of this function g of x. Okay, anytime you can read a table from left to right and you get an exponential function, then you can read the table from right to left and you get what's called a logarithmic function with the same base. Here, our exponential function has a base of 3. Our logarithmic function also has a base of 3. And you say g of x equals log base 3 of x. All right. Now, what does it mean to be able to read a table in two directions and have them be functions in both directions? Well, that means that these two functions are inverses. F of x and g of x are inverse functions. And that's actually a very important point and a very useful result about logarithmic functions. So let me write that down. Logarithmic functions and exponential functions are inverses of each other. As long as you have the same base, here both functions have a base of 3. As long as you have the same base, logarithmic functions and exponential functions are inverses of each other. Okay, what I'd like to do now is look a little bit closer at this table and then practice kind of translating between exponential form and logarithmic form. So what this table is telling us, for example, if I look at this last row here, this table tells us that 3 to the 4th equals 81. But there's another way I can say this mathematical statement, and it's a little more involved, but I think it's very useful when you go back and forth between logarithmic and exponential forms. So here's how I like to say it, and I do encourage you to practice being able to say it this way. You can say that 4 is the power, or the exponent, 4 is the power I raise 3 to in order to get 81. 4 is the power I raise 3 to in order to get 81. And the reason that's useful is now I can write this written statement mathematically in the following manner. I can say that 4 is the power I raise 3 to in order to get 81. And you can really see how these two mathematical statements are truly interchangeable, because both are read in exactly the same manner. 4 is the power I raise 3 to get 81, and 4 is the power I raise 3 to get 81. We can do the same thing with every number here, right? I can say that 2 is the power I raise 3 to to get 9, or 2 is the power I raised 3 to get 9.